Ben. So today we're going to be working on expressions and equations, and we just got a few problems with us. This is pretty mathy this time, but hopefully you'll have fun doing it, and whoever else comes. Well, this will be fun. Should I read the directions too, Andrew?
Sure, Carlin, do it.
Okay, or is Kevin doing it? I don't know. Okay. So first, we're going to talk a lot today about units digits. So on top it says unit digit refers to the single digit that comes just before the decimal in a number. And then what we have to do is fill in the chart and kind of look out for patterns. And then later below, we kind of use that to answer the questions below that.
Should I start off with example one? Um, so everyone knows what 2 to the first power is, right? Yeah, so 2 to the first power is just simply 2. And 2 to the second power is 2 times 2, which is 4, yep. And then times 2 again gives you 8, yep. And 8 times 2, 16. So we only want the units digit, so we're only gonna write down 6. And then since we only want to find the units digit, we can just multiply 2 by 6. So we'll get 32, but we only care about the 2 digits, the units digit, so it's 2. And does anyone want to figure out what 2 to the 6th power is? Yep, 64. And the units digit is a 4. And 4 times 2 gives us 8. So the units digit for 2 to the 7th power is 8. And from this, you can see that, never mind, let's do one more. 2 to the 12th power. No, 2 to the 8th power. So that's 8 times 2, which gives us 16. So the units digit is 6. So from this, we can see that the numbers 2, 4, 8, and 6 basically just repeats. Yeah, it just repeats. So if 2 to the 4th power is 6 and 2 to the 8th power is 6, does anyone want to take a guess on what 2 to the 12th power is? Yep, that thing, which the units digit is also 6. Um, so basically, 12 divided by 4 gives us 3 with a remainder of 0. And anything with a remainder of 0 gives us a units digit of 6. We can see that with 2 to the 8th power as well. 8 divided by 4 is 2 with a remainder of 0. So that also gives us 6. And anything that gives us a remainder of 3, for example, 7. 7 divided by 4 is 1 with a remainder of 3. That gives us a units digit of 8. And a remainder of 2 gives us 4. And a remainder of 1 gives us 2. So what's 15 divided by 4? What's the remainder of 15 divided by 4? Come on, Andrew. What's the remainder? Alright, so 15 divided by 4. That gives us 3. With a remainder of 3, I think. Yeah. So if you have a remainder of 3, according to this pattern, the units digit is 8, I believe.
Okay, so since it's just you, Ben, could you help me like try to figure out number 2? So for this one, we're doing sevens, and can you just like tell me the units digit of like each thingy? Just type out like for the first one, 7 to the first, what the units digit of that's going to be. Okay, and then for the next one. So if 7 squared is, ooh, you are typing a lot of numbers. Okay, so 7 squared, could you just type the entire, like what is 7 squared equal to? Okay, so 14 is equal to 7 times 2, but what we're looking for is 7 to the second power. So do you know what like exponents mean? Yeah. You're good. Okay, that is good. $49, yeah, okay. So then let's just do the units digit of that, which is going to be 9. And can we just keep going? You can just type the units digit if you want, or like the whole thing. Okay. Is that for 7 to the third? Yeah, I think so. And if you want, you don't actually have to like do the entire 7 to the fourth here. What you can do is just take the units digit of 7 to the third, which is 3, and then multiply that by 7. And that's easy. That's like a lot easier to do in your head. So okay, so the units digit of that is 1. And then we don't even have to like actually calculate 7 to the fifth. Instead of calculating it, we can just look that for 7 to the fourth, the units digit was 1. And if we multiply that by 7, we'll just get right back to 7. And so the same thing here, you don't have to actually do the entire 7 to the sixth calculation. You can just look at the units digit of 7. So Vin, could you just tell me like what the rest of these are going to be? Remember that like we don't really need the entire number, we just want the units digit. Okay, Thank you. So that's a lot of numbers. We have 1, 7, 9, 3, and then 1. Okay, so this like basically shows us the pattern for what's going to happen. We see that for every 4 like exponents, the numbers repeat. So the pattern is going to be 7, 9, 3, 1, 7, 9, 3, 1, and that just keeps on repeating over and over. So if we wanted to calculate 7 to the 21st, the units digit for this number, what we would do is see the remainder when we divide by 4. So 21 is not a multiple of 4, so we know that like the units digit won't be 1, and it'll be something else. So can you tell me like what the remainder will be if we divide 21 by 4? Okay, so basically what we're looking for is like a pattern in the units digits. So remember, we don't like care about the entire number. So like we could have like 2, 4, 3, 7, 6, 1, but all we care about is this last digit. And we're trying to look for a pattern in the last digit for 7 to the whatever number, right? So if we look at 7 to the first, the units digit is 7. 7 to the second, the units digit is 9. And if we keep going, it goes to 3, 1, and eventually it comes back to 7. So if we're only looking at the units digit, it keeps on repeating itself over and over. So after every 4 like exponents, so like after 7 to the 4th, it repeats back to 7, 9, 3, 1. And so basically, to find any units digit, basically what we have to do is just see like where we are in this pattern. So since it repeats every 4, my voice is dying. Okay, so my voice was somewhat dying. But anyways, since it repeats every 4, what we can do is divide any exponent by 4 to see what the remainder is. So 21 divided by 4 will give us 5 with a remainder of 1, right? So do you understand like this far? We're basically trying to find like where we are in this pattern, right? So since we have the remainder of 1, we know that will be basically 7 to the first. If we had a remainder of 2, the units digit would be like 7 to the second. If we had a remainder of 3, it would be like 7 to the third. And if we didn't have a remainder, or like a remainder of 4, because 4 divided by 4, works out, then we would get a units digit of 1. So in the case of 21, because the remainder is going to be 1, we know that the units digit is going to be 7, right? Does that like kind of make sense? And if it doesn't really make sense, like that's okay, because I don't know, I'm not really good at explaining. But the next one makes a little more sense. If we look at 7 to the 25, that's 4 after 7 to the 21st, right? And we know that the pattern repeats every 4 numbers. So we can just tell that it's going to be the same exact number because it's 4 more than the last one. And so you might be wondering, like, why does this really matter? Because it's kind of like pointless to just fill out these boxes. So let's look at like one of the problems for a sec. I think I just want to talk about number 4 for a second. So we know that for both 2 and 7, the pattern repeats every 4 numbers. So every 4 numbers, we get like a repeat. So let's look at the exponents here. So 2 to the 100th. Do you know if 100 is divisible by 4? Okay, yeah. So 100 is divisible by 4, and we know that because there's 4 quarters in a dollar.
Oh, yeah.
So because 100 is divisible by 4, the units digit is going to be 2 to the 4th, or 6. Because if we're counting by 4s, every 4th repetition will give us 6. So we know that the units digit for 2 to the 100th is going to be 6, right? And then for 7, 101 is 1 more than 100. So we know that that's not going to be divisible by 4. And instead, we'll have a remainder of 1. And so could you tell me what units digit it will be if we have a remainder of 1? Remember, we're looking at the 7 to the n thingy here. So we look back again at 101 divided by, oh Lord, divided by 4. We're going to get a remainder of 1, right? So if we get a remainder of 1, then do you know the corresponding units digit for any remainder of 1? Yeah. So it's just 7 because we know that for anything with a remainder of 1, we'll always get 7. So basically, since we only care about the units digit, we can multiply these two numbers together. And could you just tell me 6 times 7? 42. And the units digit at 42 is just going to be 2. So that's how you do these type of problems, basically. You just find the pattern and then find where the exponent is inside of the pattern and do the math from there. So real quick, before we go on to the next problem, you should probably do the box 3 for the 9 exponents. So if you want, you could just start typing them out. Okay, so we have 9, and then 9 squared. We have 1. Huh. I did not know this was the pattern. So what comes after 1? Okay, so then it's just going to be 9 again. You can probably guess the next one. Yep. So this is the pattern for 9 to the n. So if we look at 9 to the 102nd power, can you like take a guess at what that's going to be? Yeah, so it's going to be 1. And so the pattern here is basically because it repeats every 2 exponents. A really easy way of telling what it's going to be is just by looking at whether the number is even or odd. So if we look at all the odd exponents, the units digit is going to be 9, and all the even exponents, the units digit is 1. So since 102 is even, you can guess that it's 1. And so for the next one, you can look at this big number, and even though it looks really scary, you know that it's odd, and exactly it's going to be 9. All right, so let's try one more. Let's go to number 5. And remember, the 9's pattern is just evens or odds. So 9 to the 99th, do you know the units digit for that? Yep, it's going to be 9 times 7 to the 199th. So this one's a little harder because 199 kind of have to divide by 4 and see what the remainder is. So you can try figuring that out. Okay, yeah, so it's going to be 3 this time. And we know that because if you try to divide this out, you'll get like a remainder of 3 basically. And we know that 7 to the 3rd is 3. And so then now we can just do 9 times 3, which is a little easier than all of the other things. Yep, so it will be 27, and then if we take just the units digit of that, we'll get 7. Okay, so basically the rest of these problems are kind of just the same thing, but for some of them, you might actually have to do a little more simplification. So real quick, before we leave, I kind of want to do like something like number 11. So 63 to the 63rd. we haven't actually had any problems with looking at the patterns for 63. But what we do know is that 63 is equal to a lot of things. Let's see.
9 times 7.
9 times 7. Yes, that is a good answer. So 63 is equal to 9 times 7 to the 63rd. And so our exponent rules tell us that we can just distribute this number. And now we get a lot more manageable problem because we know the patterns for 7 and we know the patterns for 9. So for some of these problems, you have to like split them up into little other problems and then go from there. But I think we're getting around time for what we have today. So Carlene, would you want to like give us some goodbyes?
Sure. Benjamin, and hopefully anybody's watching this, hopefully you learned something today about exponents and like how they kind of work. I think the big thing today we learned is to look for the patterns, and if they go in fours, then you can tell what the next units digit would be by dividing by 4. And then if they're going in twos, you can easily do by odds and evens. And then you can approach problems like the ones down here by breaking it down and using the patterns that we learned to figure out the units digit pretty easily. So hopefully this was fun for you, Benjamin. Anybody else who's watching.